Hello and welcome to today's session where we are going to discuss the difference between two overlapping correlation coefficients. Now what does that mean? I have, let us say, three variables x, y and z. Here I am going to test the difference between the correlation coefficient of x and y and z, and x and z. So I would like to test the difference between the overlapping correlation coefficients. Okay. Now what could be the research question that you would like to answer using this? That is the difference between two dependent correlations sharing a common variable significantly different from 0, right? So let us say I have, as I told you earlier, I have three variables x, y and z. Okay. Now let us say x is the independent variable, okay, and y and z are the dependent variables. Now I would like to see the correlation. I would like to test the correlation with the overlapping variable. Okay. Now let's see. Where do we apply this test? I would like to apply this test to assess the null hypothesis of zero correlation between one pair of variables to that of a second overlapping pair of variables. Okay. Now this example may bring things more clearly. Is the correlation of variable x stronger on y than on z? Okay. To simplify that, the r of xy, that is to say the correlation coefficient of variable x and y, is it greater than the correlation coefficients of variables x and z? Okay. So here x is the overlapping variable. Okay. I am just checking, is this r stronger than is this r value? Fine. Then we assume here that the data is normally distributed, and when I am running this test in R, the package that I require, okay, is the psych package. So you can install this package, and once the installation is over, you can put that package in library. Here I have created a simple hypothetical data which can be used for running the test. Now the first, the correlation coefficient of variable x and variable y is taken to be minus 0.2, okay, and the correlation coefficient of variable y and variable z is taken to be minus 0.28. Correlation coefficient of variable x and variable z is 0.3. Okay. This is all made up data, but when you have separate variables, you can easily calculate the correlation coefficient. Okay. Now the sample size that I have taken is 123. Now how to run the test? Okay. Now when you are running the test, the primary function that I would call upon is paired r. Okay, paired dot r. So here first I am taking the correlation coefficient of x and y. Okay, then I am taking the correlation coefficient of y and z. Then I am taking the correlation coefficient of x and z. Okay. Now you can see this is put in the same sequence. Okay. And what is this 123? The 123 is my sample size. Now two-tailed test. Okay, this is two-tailed. I say true. If you want to test the one-tailed test, you can simply put it as false. Okay, once I run this, I get the, okay, this is the output. Now this is how your output would look like. It tells you the test that I have run is test of difference between two correlated correlations. Okay, the t value I get is 0.77 with a p value, that's a probability value of 0.44. Okay, this is lower than, this is higher than the threshold of 0.05. Okay, so in this case, I have reasons for accepting the null hypothesis that there is no correlation. Okay, that is zero correlation. Okay, so if you wish to have further, if you want to just read further documentation on how this paired R works, you can just run this with a question paired.r, and when you run this, you get the entire documentation in the help. Okay, test of difference between unpaired or paired correlations. So this is the entire documentation available. You can read this. That will give you deeper insights. Hope you liked this video. If you have found this useful, do like, share and subscribe, spread a good word, and definitely you can share your ideas and opinions in the comment section. Thank you for watching.
Audio Jungle.